So the chain rule is how you take the derivative of composite functions. So the big long formula is the derivative of f of g of x equals f prime of g of x times g prime of x. So what that means is if you have two functions like
marker difficulties.
g prime of x equals 3x plus 1, and then f prime, or f of x, equals just something squared. Then f of g of x is going to be 3x plus 1 quantity squared, and that's f of g of x. And then for the chain rule, you're taking the derivative of that. So the derivative of 3x plus 1 quantity squared, so it's f prime, so you bring down the 2, times g of x, so g of x is 3x plus 1, times g prime of x. So the derivative of that inside is 3. So you're left with 6, 3x plus 1, which equals 18x plus 6. You can check and make sure this works if you want. If you FOIL that function out, if you start with 3x plus 1 and you multiply it out, then you get 9x squared plus 6x plus 1. And then if you use the power rule, you get 18x plus 6. And as you can see, they're the same thing. So it works. But if you're dealing with a function that's raised not squared, but say if we were raising this to the fifth all of a sudden, then you couldn't just FOIL it out like that. So that's where you have to use the chain rule. So if you were doing it to the fifth, then it'd be 3x plus 1 to the fifth. So f prime, so something to the fifth. So you bring down the 5, and it's something raised to, so now that's going to be raised to the 4th. So it's that, raised to the 4th, and then f of g of x is, we're still using 3x plus 1, so it's 3x plus 1 to the 4th, times g prime of x, which is still 3. So that becomes 15 times 3x plus 1 quantity to the 4th, and that is the derivative of 3x plus 1 to the 5th.